notation and problem solving. So we've done 3 lessons of function notation. As you guys notice, they're all short. Probably could have all been 1 lesson. Okay, but good thing we kind of spaced them out with who's gone and whatnot. It's kind of made things a little helpful. So today's function notation and problem solving. Tomorrow's interpreting graphs. Okay, that's the last 2 concepts of Unit 3. Okay, so first off, using function notation. In lessons 2 and 3, we solved problems about relations defined by an equation. In this lesson, we solved problems where function notation is used to define the relation. In lesson 3, assignment question number 6, we had the following scenario. A candle manufacturer found that their long-lost candles melted according to the formula of negative 2t plus 12, where h is the height of the candle. Okay, which makes sense. It's negative, so it's burning. So it's decreasing value. The relation between the height and the time is described by an equation. The relation is a function because for each input there's only one output, so it can be described using the function notation below. A candle manufacturer found that the long-last candles melted according to the formula h of t, which stands for what?
F of x.
Yeah, your f of x, but in this case it's the height, right? But yeah, you're right, f of x, which is the y. In this case our y is height. Negative 2t plus 12. H is height, t is hours. Okay, it's another time and height thing. Okay, it's one of the more common things you'll compare is height and time. In this example, notation of h of 4 is simplified way of representing the height of the candle after 4 hours. So h of 4, if we just want to do that real quick, negative 2 times 4 is negative 8. Negative 8 plus 12 is 4. So the height of the candle is 4 centimeters after 4 hours. Okay, so let's look at this here a little closer. Okay, a candle manufacturer found that their long-lost candle, I don't like saying that, but melted according to the formula, negative 2t plus 12, or h is the height. So we already know this. Use a graphing calculator to sketch the graph of the function and show the graph on the grid. So we'll go ahead and get that your calculator back out. Okay, I don't need it for here, but you guys can get yours if you'd like. Okay, I went by ones for my table, and then I'm going to go ahead and draw my line here. Okay, so that's what the line would look like. Remember, common sense tells us that everything here and everything here is not real, right? Because over here, why is this not real? Well, it could make, the biggest one, guys, is this is negative time. Okay, negative time, we can't have negative time. Okay, technically they could make a bigger candle, could burn at the same rate, right? I mean, we don't know. I understand what you're saying, but the biggest thing here is there's no such thing as negative time. Okay, down here, there's no such thing as a negative candle. Okay, yeah. All right, so what it wants to do is determine the value of h of 5. So what is the height after 5 hours? So you can do that table in your calculator. You can put trace 5 enter in your calculator. That will all work. Okay, you should get 2. H of 5 is 2. Okay, write in words the meaning of h of 5. So in words, this means after 5 hours, the candle is 2 centimeters. Okay, evaluate the following and explain each of their significance. H of 0 means what? Full candle, which means the starting amount hasn't burned. So this significant is brand new candle. No time burnt. Or lit, whatever you want to call it. Okay, what's that? Oh. Okay, good. So evaluate the following. So this one would just be 12, right? Or no, yeah, 12. The starting point. Y-intercept. H of 6. Okay, 6. What's that? 0, right? So that means candle is gone. What's that?
What word is
Brand new, no time burnt.
I mean above that, the Z one.
It's 2 centimeters.
Oh, okay.
Oh, this right here? Sorry. Yeah, 2 centimeters. Thanks, Josie. Okay, h of 8. h of 8. If I do h of 8, guys, I get -4. The significance is not possible. We can't have a candle that's -4 centimeters high. Well, but remember, okay, these are all great thoughts, but remember, if it's dripped 4 centimeters below the table, it's still 4 centimeters. Okay, no, that's funny. That's a good question. How long will it take for the candle to burn down to a height of 7 centimeters? So we want to know when it's going to be 7 centimeters. Is that a x value, or t, or is that a h value, y? It's a y, so that's giving us a y. So we're trying to figure out 1, 2, 3, 4, 5, 6, 7. We're trying to figure out what this point right here is. Okay, well, we can solve. Or you can do your calculator, right? You can do the intersect. Okay? The biggest thing with this unit, guys, you need to understand that it's cohesive in the sense that I can use my calculator, I can use algebra, I have a lot of tools because it all comes back to the same answer. So I'm not going to use my calculator this one. You can. Okay, I'm going to put in 7 equals -2t plus 12. I'm going to minus 12. -5 equals -2t. What's my last step? Good, I'll say it at once. Yep, 5/2, so 2.5. So t equals 5/2, so how long will it take? It'll take 2.5 hours. But you could have got the same thing with your calculator. Okay? You can check this how? How could you check that answer? Your calculator, but also?
Doing x as like...
Right, I can put 2.5 for my t. So I can put 2.5 right there. Okay? 2.5 times -2 is -5. -5 plus 12 is 7. So it works. We can check it that way. Suggest an appropriate domain and range for the function. So this is where I want you to use logic. What's the domain of this graph? What can your time be? Right? Your time has to be between 0 and 6. At 0, you have a full candle. At 6, okay, you have no candle. Okay? What's your range? Right, the height, the brand new candle is greater than or equal to 0. The brand new is 12. That's not a 10, that's a 0. So when it's burnt all the way down, it's 0. When you first get it, it's 12. Okay, any questions? Okay, that's it, short and sweet.